Hello, hi and namaskara. My name is Kirtan and I am a second year medical student studying in a government medical college. Today I will be talking about the topic Principles of Hemodynamics. So this is an important topic and a 3 marks question can be asked in the board examination. So in this topic we will discuss about the subtopics that are types of blood flow, the peripheral resistance and also the Poisonhagen formula. So let's start this video. Before starting this video, if you haven't subscribed to my video, please subscribe for more physiology videos like this. So let's start. The first one is the types of blood flow. There are majorly two types of blood flow that are laminar and turbulent blood flow. The laminar blood flow is nothing but the streamline flow. In this, the velocity slowly increases towards the center of the vessel. So imagine that this is the vessel and this is the layer of blood which travels close to the blood vessel wall. So towards the wall the velocity will decrease because of the frictional resistance provided by the vessel wall. But towards the center the friction will be less and therefore the velocity will be more. So therefore the velocity slowly increases towards the center of the vessel. It will be max in the central layer of the vessels due to the less friction. So there is also one topic called as critical velocity. What is critical velocity? They can ask in the board examination. Critical velocity is nothing but the velocity above which the flow of blood becomes turbulent. So above this critical velocity, if the velocity increases, the flow of blood will become turbulent. So the next blood flow is the turbulent blood flow. It occurs when the velocity increases the critical velocity. The turbulence depends on the vessel diameter and the viscosity of the blood. So there is one formula, that is Reynolds number. This Reynolds number provides us with the probability of the flow that it will become turbulent or it will remain laminar. So this is the Reynolds number. Here this means density, diameter of vessel, velocity of flow, velocity of blood flow, and this is the viscosity. So Reynolds number is nothing but the probability of whether the flow will become turbulent or laminar. So when the Reynolds number is less than 2000, it will remain laminar blood flow, and when it's more than 3000, it will become turbulent blood flow. So this is about the types of blood flow. Now we will talk about the Poisonhagen's formula. So about the Poisonhagen formula, it gives the relation between viscosity of fluid with the radius and the length of the tube. So this is the formula for that. This is an important formula and is must to remember because this can be asked as a direct question in the board examination. So we'll define what are the terms here. So F is nothing but the flow of blood. We are calculating the flow here. P means this is the difference in pressure difference between two ends of the tube, because we are calculating the relation in the tube. Okay. So this is pi by 8, this is 1 by viscosity, this is viscosity. R is radius of the tube, and L is the length of the tube. So the flow of blood depends on the pressure difference, the viscosity inversely, and also the length of the tube inversely. It is directly proportional to the R to the power 4 directly. So R to the power 4, that is nothing but the radius of the tube, plays a major role in the flow of the blood. So there is also one formula, that is flow of the blood equals to the pressure in the tube divided by the resistance to the flow of the blood. So by substituting this formula, in this formula we'll get resistance as 8 into viscosity into length of the tube divided by 4 times the radius of the tube and the pi. So this is the formula for calculating the resistance of the flow. So next we'll talk about the peripheral resistance. Peripheral resistance. This peripheral resistance is nothing but the resistance offered by the vessel or the blood to the flow of the blood. So it can again be dependent on radius of the blood vessel and the viscosity of the blood. So these are the two major depending factors which affects the peripheral resistance. So let's talk about the radius of blood vessel. It is also called as vascular hindrance. When the radius is halved, the resistance will become 16 times. And when the radius is multiplied into 2, the resistance will become divided by 16 times. So it will become something like 0.06 into the resistance before. So now we will talk about the viscosity of blood. The viscosity of blood again depends on various factors, that is hematocrit, composition of the plasma, resistance of red cells to the deformation and the temperature. So we will talk about these factors one by one. The hematocrit. This is the packed cell volume. That is nothing but the red cell volume. When the red cell volume increases, that is in the case of polycythemia, the hematocrit increases and also the viscosity of blood increases, which increases the peripheral resistance and thereby decreases the blood flow. And in the cases of anemia, the hematocrit decreases and the viscosity of blood also decreases, thereby increasing the flow of the blood. The next one is the composition of the plasma. So it is nothing but the concentration of the plasma proteins, that are albumin, globin and such plasma proteins. It is increased in the case of multiple myeloma and decreased in the case of hypoproteinemia. So the next factor is the resistance of red cells to deformations. In the case of hereditary spherocytosis, the red cells are resistant to the deformation. So in that case, the viscosity increases and thereby increases the resistance to the blood flow. The next factor is the temperature. When the increase in the body temperature, the viscosity decreases, and in the decrease in the body temperature, the viscosity increases. So these are the factors under the viscosity of blood, which is the major factor in the peripheral resistance to the blood flow. So we will talk about other two topics which can be asked as a board examination question. The first one is the plasma skimming. So imagine this as the blood vessel. So in the periphery, the blood contains less amount of RBCs, but in the center there will be more RBCs. So when this blood vessel divides into two small blood vessels, the blood from this big blood vessel, the peripheral blood goes to the small blood vessel, not the center one. So when this peripheral blood goes to the small blood vessels, the number of RBCs will be less, because in this the periphery contains less RBCs. So 25% of hematocrit goes to the small blood vessels. So this is called the plasma skimming, because on the periphery of the blood goes to the small blood vessels, and this contains less amount of RBCs. So this is skimming, that is plasma skimming. The next important question that can be asked is the critical closing pressure. It is the pressure at which the flow ceases or stops. It is mainly due to some pressure is required to push red cells through the capillaries. So therefore, when this pressure is absent, there will be nothing to push the red cells through the capillaries. And some blood vessels are surrounded by tissues that exert pressure. So to overcome this tissue pressure, we need some pressure for overcoming this. So this is called the critical closing pressure. So this is a graph of the critical closing pressure. So from here, the critical closing pressure starts and the flow increases. Before that, the flow will decrease, though there is pressure that is not more than the critical closing pressure. So in this video, we discussed about the types of blood flow, the Poisonhagen formula, and also how to calculate the resistance of the blood flow. We discussed about the peripheral resistance and its main factors affecting it, that is radius of blood vessel and the viscosity of the blood. And also we talked about plasma skimming and the critical closing pressure. So this is for this video. If you found this video informative, please like, share and comment, and also don't forget to subscribe. I'll provide the notes for this video in my Telegram channel. The link will be given in the description below. Thank you.